Here it is, our last example in the chapter is this beast. We've got 3 logs. Here we go. It's the log of x plus 2 with base 5 plus the log of x minus 7 with base 5 equals the log of 10 with base 5. Okay, so where do we get started here? Well, we're going to take advantage of that same property of the way that logs will simplify with exponentials. But there's a little bit of work to do here first. Because we have multiple logs going on, we want to begin by condensing some of them. The way it is, we can't work with it with those properties. Really what we need is just a single log here on both sides. So this one's good to go. We've just got a single logarithm on the right side. We want a single logarithm on the left side. So we are going to condense those 2 logs together. So if you remember that property of condensing logs when you're adding them, we can write this as a single logarithm with base 5 if we multiply the 2 arguments. So this is what it would look like here. A single log base 5, x plus 2 multiplying with x minus 7, and then we're just copying that right side. Now I've written it this way, but what do we need to do now? We need to FOIL all of that to multiply them. And here's what it will come out to after foiling. So the x times the x is the x squared. That middle term, I went ahead and combined like terms already. X times negative 7 combines with 2 times x. Negative 7x plus 2x, right? And then the 2 times negative 7 is the minus 14. And again, the right side, well, it's fine the way it is. It's a single logarithm already. Just kind of bring that down. Okay. So in a sense, it's like we isolated a logarithm, right? We need 1 log base 5 here and 1 log base 5 there. So what do we do from here? We really want to cancel out these log base 5s, right? Well, how do you cancel out a log base 5? You take whatever the base was and you apply that same property. So, well, our base is 5. So we are going to put both sides in the power of 5. Again, it just feels like a strange thing to do to both sides of an equation, but logically it's got to be true if we're doing the same thing to both sides. We're going to say, and this is a lot of writing here, but 5 raised to that left side equals 5 raised to that right side. And yeah, that's a lot. 5 raised to the log of x squared minus 5x minus 14 with base 5 equals 5 raised to the log of 10 with base 5. Okay. Give you guys a moment. Why do we do this? Well, because the exponential with base 5 cancels with the log base 5, and it actually does it on both sides. So our next line is x squared minus 5x minus 14 equals 10. All of those logs canceled out. And at this point, once our logs are completely gone, we just got to think to ourselves, all right, where do we go from here? How do we solve this? It's like a brand new question. It's not just a couple of quick steps to the answer like the other problems we've looked at so far. Like, oh, this is a quadratic equation. What I want to do is subtract that 10, make it equal 0, and then use quadratic formula. So I'm going to do that. Like, yeah, this is a long problem, right? So my a equals 1, my b equals negative 5, my c equals negative 24. So we'll put those into the quadratic formula. Negative b plus or minus b squared minus 4ac all over 2a is all that. Turns out, though, this is going to have a couple of pretty clean solutions. Well, there, that will be positive 5, right? What's inside that square root, if you take the time to compute that, turns out to be 121, and the 2 in the denominator. So x equals 5 plus or minus the square root of 121 over 2. And you might recognize square root 121 as 11. Well, to go further, I'm going to go ahead and write the two separate lines. 5 plus 11 over 2, 5 minus 11 over 2. And that gives me these two answers, x equals 8 and x equals negative 3. Okay. Now it seems like we'd be done at this point. This is one of those moments as a teacher, I almost feel bad for students. I don't feel bad, but I almost do. Turns out only one of these is actually an answer. The other one is an imposter. You might remember the word extraneous. When it comes to solving logarithmic equations, sometimes extraneous solutions pop out. So how do we know? Okay, here's what we're going to do. We're going to take those two answers one at a time, and we're going to plug them back into the original statement. So let's start with x equals 8. My original problem I was given had this. Of course, there was an x there and an x there. So I put in 8, the log of 8 plus 2 base 5 plus the log of 8 minus 7 base 5 equals the log of 10 base 5, plugging the 8 in for the x's in the original problem. Let's just take a look. What happens when we do that? Well, 8 plus 2 is 10, 8 minus 7 is 1. So that would bring us here. And again, we're just saying, does this work out to be a true statement? Hey, do you recognize the log of 1? Isn't the log of 1 always 0? So this whole thing in the middle is 0, and I've got the log of 10 base 5 equals the log of 10 base 5. Yep. That is a true statement because that middle one goes to 0. So x equals 8 is the legitimate answer, which you can probably take a guess at what the extraneous one's going to be. Let's try negative 3. Now, why does this play out to be extraneous? I'll explain. If we plug negative 3 into the original x's in the original statement, what's going to happen? Well, negative 3 plus 2 is negative 1. Negative 3 minus 7 is negative 10. And this is supposed to add up to the log of 10 with base 5. And you look at that, well, what's the big deal? So it turns out that the log of a negative number is undefined. I'll just show you guys all this, all my notes. The log of it, this is not something that we have come across yet. Certainly not something I would expect you guys to know at this point. It's never come up before. You can only take the log of a positive number. You can't even take the log of 0. The log of 0 is undefined as well. You can only take the log of a positive number. So as soon as, after we simplify, both of them were negative, in fact. I mean, if only one of them was negative, that would be enough. But both of them turned out to be negative. Neither one of these are actually numbers. X equals negative 3 leads us to an untrue statement, since we get these two undefined values. And I think that's all I'll say about it. I guess one thing to make really clear, it's not the fact that the x is negative, It's the fact that after we simplify, we get negatives. You might have a negative solution and it be okay, because you might add numbers that turn it into positives, but here that did not happen. Okay, so in the end, x equals -3 is extraneous. The answer is x equals, the one answer is x equals 8. All right, in the next video, I'm going to present something for you guys to solve, and you'll get a chance to work one out on your own, and then we'll do them together.